diploma in mining from RMIT, and soon after graduating came to Western Australia, got involved in underground mining. And then after, you said about 15 years experience, decided it was time to set up business, and was one of the founders of Burncut Group, which is now a $1.5 billion operation. I hope you'll explain why the name Burncut came in, because I thought it was fascinating. Steve, are you ready to present?
Thank you. Thanks, Steve. Good morning, ladies and gentlemen. Yes. Thank you for the opportunity to speak today. I've got a fair bit to get through. It's very hard to condense the nature of this business into a 20-minute discussion, but we'll do our best. So, as Stephen said, I studied at RMIT, finished there in '74, came over to WA and was recruited by WMC to Kambalda nickel operations. Started at Silver Lake Shaft in that year. KNO was regarded as a very as a boom town, and it's a stuff of legends that an integrated nickel operation consisting of mines, a town and community facilities, a nickel concentrator and a nickel refinery in Kwinana were constructed in a few short years. Try that today. So it's a very can-do environment, and so for young mining engineers, they were thrown a lot of responsibility to develop and operate underground mines, covering shaft and decline operations. And other than a short stint at Cleveland Tin Mine in Tasmania, I spent all my time with WMC through to '87, finishing as mine superintendent at the Vatukoula Gold Mine in Fiji, which is a joint venture between WMC and Emperor Gold Mines. So in mid-'87 we started Burncut. I moved to Frank Lubbock and Associates, which is a mining consultancy group in Kalgoorlie, and during that time, in the same year in '87, we started Burncut in August, and the first contract was to develop the West Australia decline at the Bellevue Gold Mine for Queen Margaret Mines, some 400 kilometres northwest of Kalgoorlie near Leinster. And today we find the Bellevue mine has restarted. So from that initial underground contract, the business developed to include a range of complementary entities. 2020, we have a calendar financial year, by the way. The privately owned group is a large complex business employing over 4,500 people with turnover approaching $2 billion per year. Just looking at what it's made up of, the core business remains underground mine contracting through Burncut Australia. However, there are a range of businesses and functional entities that complement the business. These are three distinct operational areas: the Australian Underground Contracting Business, Burncut Australia; Burncut International, which manages the international work, which currently involves contracts in Saudi Arabia, Mali and Burkina Faso, but we've worked in South Africa, Zambia, Ghana, the DRC and so on, all the places you want to visit. Particularly Saudi Arabia if you want to go on the square. And the other businesses and Moe Engineering Group, which is a very important element of the group, covering mechanical, electrical, engineering services, equipment hire, manufacture, etc. But I can't get into too much detail. It'll take a session in itself to go through all that. The other businesses, Jetcrete Australia is a shotcreter, the largest shotcreter in Australia, which involves spraying concrete for underground support. Raising Australia is a raise driller, and what they do is drill holes up to 5 metres diameter and up to 600 metres long for underground ventilation, etc. An Indigenous training business called BOAB, Sano Health, which is an industrial health business headquartered in Melbourne actually, but they work all over the place. Mining Plus, which is the mining consultancy group, mine design, etc., with offices in Perth, Adelaide, Melbourne, Brisbane, Lima in Peru, Denver in the US, Toronto and Vancouver in Canada and Cornwall in the UK. And that covers all of those. So it's quite an interesting, diverse group, but very complementary and they're all very important parts of the business. For those not too familiar with underground mining, this is a typical drill jumbo, electric hydraulic, and you can see the face there out of an open cut, ready to take the first round. That's a new mine for Norton Goldfields up at Paddington. And where are we? Hold on. I need to get a little video happening. Can the techo help me how to do that? It's actually embedded in that. Or can I go over there? Oh, hold on, I've got it, no worries. So just a little view of the first blast of the two portals going into that mine. Oh, hold on, I need to transfer this across now, bear with me. Apologise for this. I'm going to go again if I can. I want to bring that up there, that video. Okay. Okay, there you see it. We've blown it up. I'll run that again, it's very brief. So that shows the two first cuts of a new mining operation starting in Kalgoorlie. If I then go back to our presentation, exit that. Yeah. Okay, and then going on from there, I want to flick onto the next slide.
Yep.
Okay, and that's the end result. A couple of cuts in, you'll see that we've advanced, we've shotcreted the portal, and we've bolted and meshed it, ready to take another round. So that's a typical cycle. So in any year, we will do about 150 kilometres of development across all operations. That's a lot. A lot of equipment, a lot of people, a lot of different areas. And we mine around about 23 million tonne of gold and base metals ore on behalf of a range of clients. In terms of business growth over the journey, that shows the revenue growth. Clearly we've had major expansion in the last 4 or 5 years. As I said, in 2020 we'll do about 1.7 billion, but we're tracking towards 2 billion at a pretty rapid rate of knots. I won't give you the profit figure, I'll just give you the trend. I don't want to give too much away, but we struggle by. But there's been a whole lot of events through that time. I mean, we started in May. The October stock market crash happened in October 87, so that got us pretty focused. We had to chase a white knight, so Thyssen from Germany came in and took out 50% of the business for a ridiculously cheap price back in the early 90s, so good for them and good for us. Then we had the financial crisis in 99. Legacy contracts refer to the boom in the 2000s where we were locked into existing rates, but prices took off, input costs took off in terms of labour and supply. The GFC, of course, in 2009, 2010, and now currently COVID-19. So what does all that mean? Well, just going back again, back in Kalgoorlie, if you were around, and Milan probably was, old dudes like me, it was really quite insane. It was like a movie scene. The place was chock-a-block. The banks were spending money like it was going out of fashion. They couldn't give it away quick enough through to regulation, which was overall a good thing. But literally, you could go to the Palace Hotel and present a feasibility study on the back of a beer coaster and they would lend you money. And of course we had Alan Bond and Laurie Connell's Rothwells and Skase sucking up everything they could get, and that was all fine until the crash happened. So, for example, in 85 to 87, January 85 to January 87, the All Ordinaries doubled, year on year 40% growth. 1st of January to 21st of September in 87, the stock market rose 56%. It was quite insane. And then, of course, the crash came. Connell, Bond, WA Inc., they all collapsed, and the banks closed up shop. So we went up to interest rates. The banks withdrew our working capital overdraft, put us under huge pressure. We had to borrow money from third tier lenders, and we were paying in excess of 20% for equipment. If you compare that to today, I think in November, early November, the Reserve Bank dropped the bank rate to 0.1%. So it means we can now finance equipment for around about circa 2%. So it was 10 times more expensive back then to buy equipment. So we were effectively expanding ourselves out of business, not being able to get working capital, which is why we had to chase a suitor or chase a white knight in Thyssen-Schachtbau. Just briefly on the Australian operations, WA is the biggest activity area. We also have Prominent Hill, which is a large-scale copper mine in South Australia. Capricorn Copper for EMR up at Mount Isa, which used to be gunpowder, which used to be something else, and it's the third time we've been there for the third different owner. So same horse, different jockey. And at the Cadia Gold Mine in New South Wales for Newcrest. Just covering off a couple of them. Jundee Gold Mine, currently owned by Northern Star, previously Newmont, previously Gutnick. That contract value to date is worth 1.6 billion, and it will run out to 2 billion, but we would assume to get an extension. It's very, very long-term work. Big scale contracts, long-term relationships. Very, very good mine. Incredibly profitable mine for Northern Star, and I'm happy to let them know regularly that it's their cheapest cost per ounce. It's their only contract operation. Prominent Hill Copper Mine. Large scale mine, trucking operation, and if we just look at a couple of things here, this represents a computerised jumbo, and that jumbo is actually drilling out the heading by itself. In this case we did a trial to operate it from the surface, but the operator only intervenes to change the drill bit. So the jumbo will drill out the heading, but if the bit goes blunt it doesn't recognise that, so to overcome that, the operator steps in, takes control remotely, changes the drill bit out of that cartridge. So that's all doable. It's only limited by the comm system in the mine. Telfer Gold Mine, we sank the shaft up there, 1100 metre, 7 metre diameter shaft, Kopi winder. Started there in the underground mine. 205 still there. Have a very good relationship with Newcrest. Like I said, we're at Cadia, and we'd have a reasonable expectation that we'll pick up the Havion deposit up in the same area. Gwalia Mine's an interesting one because it's the deepest trucking mine in the world, about 1700 metres deep, hauling up a 1 in 7 ramp, around about 12-13 kilometres. It's going to go down 2,000 metres, probably the deepest mine in Oz. They've looked at the shaft option. There's not enough tonnes volume there to justify the capital, so they're pushing on with trucks. They looked at other alternatives. So a truck takes a couple of hours to do a round trip there. So trucking is critical to that operation. Raising Australia is also an interesting one from a materials perspective. If you can imagine what those machines have to do, and this is a Robbins 121R. You can see the thrust cylinders on that machine. Here we see a reaming head. They can be up to 5 metres in diameter. That's a rod string. Each of those rods is 1.5 metres long, weighs 870 kilograms. The head weighs 25 tonne. So you can imagine on a 500 metre deep hole, you've got a dead weight of about a bit over 300 tonne. So the machine has to overcome the dead weight and then apply enough pressure or thrust on the bits to cut the rock and turn that head with all that pressure. So the stresses on that steel are immense, particularly the joints. It's very, very high technical specification billets, which are then certain kind of additives to get the strength purified to make sure there's no flaws, and then machined out. We get them out of Germany. Very expensive. The rod string's worth as much as the machine, millions of dollars. So losing a rod string is not a good thing. So we test those threads and the steel regularly with non-destructive testing to make sure there's no cracks. Can't afford to have a failure. So in a material sense, that is the kind of ultimate application. No one's come up with anything else to match that high strength steel. But it's very heavy, so if someone did, it would be a good solution. Jetcrete, shotcreting business, as I mentioned. Here's an operator remotely spraying the heading. So this is a cyclic nature, drill, blast, bog it out, cycle, shotcrete. Concrete's been delivered to the concrete pump at the back. Here's the finished result, and there's jumbos in there. You can see the shotcrete, the jumbo's in there bolting and meshing before he starts boring out another heading. A very cyclic nature. And in that process we use a laser scanner on front of the machine, developed by Murray Engineering, to measure the opening walls before we spray and then after or during to check the thickness. And that heat map represents shotcrete thickness. Number one, for QA reasons or quality control, we need to make sure we get the right thickness, but we don't want to spray too much because you're wasting product and we don't get paid for it. Previously, quality control would be coming back later and drilling hole plugs and measuring the thickness. And if you got it wrong, you had to come back and respray. So you can imagine the cost of that. This is very efficient. Innovation, a big part of our business. And I'll make the point that it's critical to any business to be innovators. My experience, best experience I can think of, was back in Kambalda, where in the 70s, all the jumbos were Gardner-Denver 3-boom pneumatic, in other words, compressed air powered jumbos. Very expensive energy. Big compressors at the central powerhouse, distributing air through 15-inch air mains to all the mines. You can imagine the infrastructure costs. And those GD jumbos were the kind of standard machine in those days, and they never really developed the product beyond that. They were selling old rope. Tamrock, now Sandvik, came along with electric hydraulic jumbos, which are far more efficient, more productive, with a trial in the 70s, and within 2 or 3 years all the GD jumbos were parked up, and Sandvik and then Atlas Copco had the market for jumbos, and GD never sold another jumbo. So the point is, if you sit on your laurels, someone will storm over the top of you. So we're kind of heavily involved in that space ourselves as a mining contractor with these other businesses, including Murray Engineering, Quattro, Jetcrete. The point I'll make about Jetcrete is, in terms of materials, obviously the mix is very important. Aggregate, cement, sand, pretty obvious. Critical aggregate size, the right sand to get the right strength. Then various additives, including super plasticizers to help it spray better and stick. Hydration chemicals to sleep the concrete to get it down underground without it going off. And then setting agents to speed up the reaction, to get it to go off quickly so we can get back in there and mine it. And then on top of that, in terms of materials, they are and have looked at synthetic aggregate options, slag options, Marcus is here, he can fill you on the detail, and a whole lot of other possible replacements for product to reduce price and improve the outcome. In terms of other innovation, the major one we're working on is this diesel electric truck. This is an old Atlas Copco truck chassis. It's completely gutted, and it has 4 electric wheel motors on each corner, no transmission, no drive lines, no diffs, a diesel generator, various control elements to make it all work. Technology's out of Germany. I'll talk about that a little bit later. We're very big on automation. I'll mention a little bit about that. The mechanisation is obvious, so not only are we collaborating with suppliers on developing product, remembering that Australia is the biggest market for large capacity trucks and loaders in the world. The unfortunate thing is all our feedback goes back to Sweden, goes into product development, and then they build it there and we export it back to Oz. I kind of philosophically have a bit of a problem with that, and we need to do something about it. Mechanisation again, Quattro have developed in-house product, paste-fill switching valves, EWP platforms, hanging baskets, etc., which are manufactured by Murray Engineering. Murray Engineering have developed their own product. We don't try and keep that in-house, we sell it to the market. Because if you do try and keep it in-house, someone will develop an alternative anyway. So get out there and flog as many as you can before they do. Digitalisation is a common theme for everyone. We're applying it across the business. What that means is a paperless reporting, data coming in from equipment real time via 4G networks or Wi-Fi through a fibre optic backbone. All that machine data, and you can imagine the hundreds and hundreds of machines we have, comes in, gets uploaded, analysed, so we can be predictive in our maintenance. And I must say maintenance discipline is one of the most critical functions of our business, because 30% of our costs relate to maintenance ownership and maintenance servicing. 30% labour, 30% material, a little bit at the end for us. So if you get the maintenance wrong, it's a disaster. You don't produce, cost you money, you get burnt both ends on the revenue and the cost side. It's a very, very important discipline for us. Electrification. I'll just talk a bit about load and automation. Loader automation is basically standard for us now. So here we see a typical console, and that could be on the surface or underground. The operator is sitting in there, but he only picks up the controls and takes over the loader when it's got a load of bucket of dirt. You then tell it to tram back, and it will go back down the drive on a predetermined route using laser scanners by itself at a faster speed and more accurate than a manual operator. So for example, when we first introduced that technology at Jundee 15 years ago, we went from a 17-tonne loader to a 20-tonne loader, which is wider, and we were able to operate that machine more accurately and faster than a manual operator. So it improved our productivity. The payback was very quick, apart from the obvious safety benefits when you've got to go into an open stope, which is an area where you can't see above you to check the ground conditions. So that's our standard, and it also allows us to operate multi-machines from one station. Automation for production drilling. We'll run those machines during shift change, so we get a few more metres out of the machine while the operators are up changing over. The issue with those is the bit changing. I haven't come up with a good solution for bit changing that works effectively. So we'll work with Sandvik to develop a longer life bit, more expensive, but so it can drill further than a conventional bit during those automation phase. Development drills. I mentioned earlier at Prominent Hill, we've done a trial operating that development drill from the surface. The drill will automatically drill out the heading anyway, but as I said, it won't change a bit. So that's what we've done, operated from the surface. The operator steps in and changes the bit as required. Electrification, I referred to that truck earlier on. This is the truck chassis, completely stripped down, adding in all the electrical components, new axles. There's an electric wheel motor directly coupled to the Kessler wheel in there on each corner. There's a whole lot of complex electrical control systems to make it work. It is a diesel genset, the original QSK 19 engine, but that's not that relevant to us. If batteries reach the stage where you get the right power density, that source could be a battery, or could be trolley assist, or could be hydrogen cell. We don't really care. At the moment, we're testing the electric drive system as opposed to trying to develop our own electric technology. Others are doing that a lot in that space. It's not our game. So why do we do that? Electric drive, as we know from surface trucks, is more efficient, more productive, less maintenance costs. We have less oil because we have no transmission, no diff. Electric braking means you hardly ever touch the service brakes. The electric energy burns off in this case as through heat exchangers, in other words kettles. If it was batteries you would look at recharge, or if it's trolley you'd feed back up into the trolley assist. So, and we do have 150 of these trucks in the business at $1.7 million each. We depreciate them over 4 or 5 years. So in the stay in business case, we buy 40 or 50 of these trucks a year. So the business case for us, because we're not seeing enough action from the suppliers in this space, they all have the same common theme of a mechanical drive articulated truck, is to increase our uphill speed and or increase payload. If we can get 10% pickup on performance, that's massive at a mine like Gwalia and for our total fleet. So while that, I do have a video of that truck, but it's too hard to bring the videos up. So that truck's been tested at the moment. We've had it at the mine, we've pulled it out to do upgrades. It's now operating at a quarry down near Pinjarra, Marty? Yeah, so we're doing more test work. But concurrent with that, we've gone to a group called First Mode in Seattle, who come from the aerospace background of all places, to develop a truck from the ground up using aerospace logic. So what that means is very, very sophisticated 3D modelling and simulation of all systems, the chassis, the drive line, the heat, the cooling, the hydraulics, the electrics. Do every simulation known to man before you start cutting steel, as I do for an aircraft. You can't build one aircraft and say, that didn't really work, we'll try number two. The simulation is incredibly sophisticated so that when they do start cutting steel, they're pretty well there. So that's the option we're going for. They're really, really out there, interesting guys, and we hook up with them regularly on video because they can't get out here. But we're feeding back all the data from the existing truck as practical information for that exercise. The first phase is the concept study, which costs about $1 million US, and now we're moving into the multi-million phase of the design, and then we'll go build. So the ultimate aim is to build that truck in Perth, in Western Australia. We don't see why we cannot. We have the skills and various providers. We would not build the truck ourselves. We'd go out to suppliers in WA, might be Geograph Engineering, to build mechanical components. We'd go out to other suppliers for the electrical components, and we would outsource, but do the build, do the assembly at Murray Engineering and some manufacturing at Murray. We would use better resources than we have to assist. So we will be talking to providers in that space fairly soon to see where we get. That's probably a 2-year process to build prototype 2. So part of the materials issues there is how do you take weight out of that truck? If you look at what Mineral Resources did, they were investing in a carbon fibre truck body facility or process. They've canned it. So they've obviously made a decision that economically it doesn't stack up. So you've got to be careful what you do. I mean, at the end of the day, steel is still the best product for the aggressive underground mining involving heavy rock or hard rock. So what we're looking at is how do we cut weight out of that design, just using standard materials, through smarter design. If you're not sure of the design, you'll put more steel in to overcome the kind of risk. But we've also gone over to Lab 22, CSIRO's Lab 22 in Clayton in Victoria several times to have a look at their additive manufacturing processes, and some of you may have been there. If you haven't, you should have a look at it, it's quite fascinating. The technology that we're particularly interested in is cold spray, where they can spray kilograms, tens of kilograms of metal powder per hour. And I do have a video which I'd like to throw up, but I haven't got time, or it's too hard. But it shows them spraying a fairly complex shape with two robots moving in unison. And you look at that and you could easily adapt that to a truck chassis and just keep drawing it along with the robot and spray a truck chassis. And that could be an incredibly complex design which you could not make using conventional manufacturing techniques, because the boilermaker just couldn't get there. So you kind of throw the design book out again, which is a problem for the old designers. So mate, forget about all that. You can make anything you want. Any design, no matter how complex, we can spray it. So where do we go with that? Do you have a kind of honeycomb chassis which is half the weight but twice the strength? They've also developed and patented the production of titanium powder. Previously, titanium is actually very, very common, but it's very, very expensive to extract the titanium metal. CSIRO have come up with a powder manufacturing method which has reduced the cost by several factors, like about a tenth, to produce titanium powder, which you can spray and make a shape. So is that a solution? So the challenge is for the people who are into materials is how do you adapt that new technology, whether it's cheaper manufacturing of materials which were previously too expensive, and how to use existing materials using different manufacturing purposes to get a better result. I'll leave it at that. Thank you.
You have time if you want to show it.
Oh, sorry, any questions?
Certainly welcome questions. Who wants to be first?
The burn cut name.
Yes, the burn cut name.
The burn cut name, okay. So way back when, there was a notorious mine foreman called John O'Byrne, who was well known through the underground industry, and we plucked him out as the front man, and we sat around having a few beers on what would we call this, or power mining. Oh, that sounds a bit like a bit of a wank. Blah, blah, blah. Burn cut. A burn cut, B-U-R-N, cut, is the initial drilling pattern in the centre of a tunnelling round, which you'll see on the burn cut logo. Any underground miner will know what a burn cut is. John O'Byrne is a play on words. So that was the logic.
So was that a burn cut when you showed us that your first opening picture?
It would have been in the centre of the face, yeah.
That was it. Yeah. Well, look, it's fascinating to hear the potential developments with additive manufacturing, which really is quite a big topic with all of us in the materials world. I'm not quite sure what to say. It's really encouraging to hear that you're thinking in these terms, and as you say, it can be done here. The IP doesn't have to go back to Europe.
If you look at Sweden, it's a high-cost country. It's a niche product, so the Chinese aren't going to bump you off. There's not enough volume, worldwide market for those things. Caterpillar, don't know whether any cat people here, but they've kind of dropped the ball in terms of that underground product development. Have been overrun by the Swedes, and the dealers in WA will freely admit that they're behind the 8 ball there. So there is an opportunity, and I just can't see why not.
Yeah, well, that's a good term. I can't see why not. That must have been your motto all along, though, I think.
Look, if you go back about these trucks, I can recall being in Burnie in Tasmania at a presentation there, and I put up the graphs of truck performance and said, and I'm talking about 20 years ago, give us a truck which does 15 clicks up the ramp and hauls 60 tonne. We're still asking the same question. They don't do 15 clicks up the ramp. So we're still waiting for a solution, and we've decided to take it on ourselves.
Well, more power to you for that. Excellent. Any other comments or questions?
Steve, you were saying that was originally an Atlas Copco truck, is that right? Did I get that right?
Yeah, it's just an existing Atlas Copco MT6020 truck chassis. It's been heavily modified to accommodate those axles. Completely gutted of most of the mechanical components except the engine. And the electrical drive system components come from Siemens in Germany. We went over to Siemens in 2014 and sat down with them and said, this is what we want to do. And they said, we can do that. But they effectively modified, they're 160 kilowatt wheel motors. The engine only develops about 570 kilowatt. With parasitic load, we only get about 430 kilowatt. So there's a lot of upside for us to get more power to those wheels with less compromise than we've had to do with this truck, because we can't do everything known to man on truck one. It's to test the system first. Prototype 2 will look at all those things, try and reduce parasitic load. So it could have been a cat truck, could have been we don't care. It's just purely a test platform.
Steve, why do we need drivers at all for these new age trucks?
Sorry?
Why do we need drivers at all? Why do we need all that front end stuff?
Of the drivers.
Why do
we need drivers going forward?
Why do we need drivers?
Yeah.
Look, you can automate trucks today, and we're working at Syama mine in Mali for Resolute, and they've put in an automated trucking system. That required a second decline,
Right.
because you can't operate any other traffic in it. And that's the practical issue with automation of trucks in existing mines. If there's other traffic, it's just not on. And I might add that at that mine, they've got operators on the trucks. They've discounted the automation system because it's just not smart enough. A truck driver intrinsically will stop for less time to let trucks overtake, and they go on the same route every time and put in big wheel ruts. You've got to stop to put a grader in, so you stop the automated truck fleet. So you've got to be careful what you wish for. So, as I said, do your homework. Because, and particularly in Africa, where an African driver is going to cost you $15 a week, why would you do it? We don't do it here. So be careful what you do. It's not, the technology's there, but it doesn't necessarily mean it's going to be economic in a certain application.
Yeah, I noticed on your concept designs you went from 4 wheels to 6 wheels. Were they going to be all driven?
That is purely a concept. Early days, all those will get flushed out in the simulation.
Yeah.
The trouble with the advantage of the 4-wheel drive truck is tyre wear is minimal. If you go 6-wheel, you've got to be very careful about the centre axle because of scrubbing, and tyres are expensive. So there'll be a lot of simulation to do on that 6-wheel option in terms of, do those wheels steer, how do you kind of synchronise everything to minimise tyre scrubbing and so on. But that's just concept at this stage. The advantage of the 6-wheel drive is you can put smaller diameter tyres on and get potentially more payload. Because the restriction is the existing ramps to around about 5 metres by 5 metres.
Question in the back. Yeah.
Steve, first congrats on all the innovation work. It's really great to see an Australian company doing that sort of work. I know it's pretty tough to do. I've got a question about how you load trucks.
How do we load them?
How you load them. It's really interesting hearing about the work you're doing to increase payloads.
Yeah.
But I can't help but think when you're loading the truck, how do you optimise to make sure you're getting, you're absolutely optimising what you're getting into each truck, given that you're also doing multiple loads per truck and trying to sort of hit that payload right at the top end.
Okay, it's a good question, because one of the issues with these trucks is the volume of the tray is restricted again by, so it's about volume and SG of the rock you're putting in it. Most of the gold ore is around about 2.6, 2.8 in situ SG, about 2/3 of that broken. So most times you cannot get 60 tonne in the truck because if you ice cone the truck up, it's chockers, it's only holding 50, 55 tonne. If you put in base metals ore such as lead or copper, which might have a broken SG of 3, you can potentially overload the truck. So you can get load cells on the truck to monitor load. They don't really function that well because the truck's at an angle, etc., etc. What we have at several mines is a scanner which scans the truck as it comes out of the portal and looks at the volume load. It's all about how much volume you've got in it. And if a truck is not topping up properly, we'll let the driver know and let the operator know. You're not putting enough in that truck. So the issue is more the SG of the rock we're dealing with as opposed to are they putting enough in. But they're loaded almost exclusively in our case with underground loaders, generally Sandvik 621s, which are a 20 tonne class loader, so about 3 bucket loads.
Yes, Paul.
Yeah, so I mentioned with the Shotcrete playing around with different additives, also artificial or synthetic aggregate. Have you actually done any field trials of any of those and anything look promising in that space?
Has it advanced?
Yeah.
Oh, we had a look at a product out of South Australia, but the inventor got his costs wrong. Just what was prohibitive. What I did fail to mention was a very important part of that Shotcrete product is plastic fibre, which gives tensile strength. About 65mm fibre goes in there in the Shotcrete mix, and that gives the Shotcrete more tensile strength. Previously, it used to be steel fibre, but steel fibre is more expensive, doesn't give as much strength, is corrosive. The plastic product or synthetic product's far better.
With all this innovation, what do you do about the intellectual property? You try to make it too hard?
Good question. And when previously we used to go outsource our ideas to other engineering groups, they would develop it and then sell it to others. So we made the point we were at a size where we need to bring that in-house, which is through Quattro Engineering and Murray Engineering. Murray Engineering have an aerospace doctor down there, Dr. Max Ong. He's a pretty switched on type of guy, the type of bloke that an average mining engineer will speak to and you nod your head wisely and walk out saying, what was he talking about? So he's heavily involved in the innovation space.
And you mentioned the work you've been doing with Sandvik on extending drill bit life.
Mm-hmm.
Could you expand on that a little bit?
What it is, it's all about the carbide and the shape of the bit. So you use a different carbide, which gives longer life, but the drilling rate drops off. So it's a compromise. If we can drill throughout the change of shift without changing a bit, we'll accept the slower drilling rate. When the operator gets down, he'll use a conventional bit, which will wear out faster, but it'll drill faster.
Okay, it really is optimising.
It's horses for courses, yeah.
Yeah, and that one for the raise boring was pretty impressive drill string you got there.
Yes, it is. It's actually very old technology. Raise drilling's been happening for decades and decades. No one's come up with a good alternative. We have looked at composite rods for when we box hole drill. That's when you actually push the head up to go from level to level, so 35 metres, 700mm, 1 metre hole, metre diameter. There's a mob in New South Wales who make high-tech composite rod. So we went to him and said, can you do it? He had trouble with the torque. It's okay in compression, far better in tension. When you twist it, couldn't handle it.
Yeah, it's pretty extraordinary. Any more questions? Well, that being the conclusion, I'm sure there are plenty that you can think of after this, but I'd just like to thank you very much, and we have a small
Thanks.
token of our meeting to remember us by.
Thank you.
We hope
Thanks,
you'll
Steve.
fill those.
Thanks.
So, thank you very
Thanks,
much,
Paul.
Steve.
Thanks, Steve.
Are there any announcements we need to make, other than this is our final technical event?